Assalamualaikum and hi everyone. Today our group is presenting about nuclear reaction in stars. So firstly, my name is Fatin Shasha Irina binti Amiruddin and I'm going to talk about what is nuclear reaction in stars. So unlike a fire on Earth, which requires oxygen and fuel to burn, stars is a self-sustaining nuclear furnace. Nuclear reaction in stars is a nuclear fusion. This involves immense pressure and temperature in the star's core squeeze and the nuclei of hydrogen atom together to form helium. It releases energy which hits the stars and prevents it from further collapsing under the force of gravity and allows the star to shine for a billion of years. So next, we're going to talk about the importance of this reaction to modern physics. So firstly, modern physics use stars to prove quantum tunneling, which is the phenomenon where particles slip through energy barriers they should not be able to cross. Secondly, it used for evidence for mass energy equivalence because stars provide the most large-scale and observable proof of Albert Einstein's most famous equation, which is the E equal to mc squared. Third, it also used to solve the nucleosynthesis. Modern physics relies on stellar reaction to explain the origin of the periodic table. Lastly, it also is the source of energy technology, which is understand stellar fusion powers research into developing sustainable fusion energy on Earth. Methodology of gathering information. Firstly, we use institutional and educational resources like NASA, MIT OpenCourseware, and ITER. Next, we use a group discussion where our group discuss with peers to share ideas, clarify difficult concepts, and divide research tasks. Lastly, we use online resources which are like YouTube, simulations, and journals. Next, we move to key challenges in stellar nuclear reactions. So first, target degradation. High-intensity particles beams are aimed at solid targets to measure the cross-sections. Therefore, long exposure to these beams degrades the target and lead to uncertainties in measurements. Secondly, background noise. Cosmic rays and natural environmental radioactivity interfere with measurements of rare fusion events in laboratory on Earth, masking the signal. Lastly is the unstable nuclei and short time scales. Explosive environments like supernovae and X-ray bursts involve unstable radioactive isotopes. They have very short lifetimes, preventing their use in traditional static and target-based experiments. Propose and implemented solution. So firstly, they use high intensity accelerators and improve target technology by developing new target production methods, such as rotating targets to distribute beam heating. This helps to reduce target degradation and extend the measurement times. Secondly, improvement on theoretical Hauser-Feshbach model. For heavy nuclei where many nuclear levels exist, physicists use statistical model like the Hauser-Feshbach approach to calculate the reaction rates. They are continuously refined with new data on nuclear structures such as level densities and photon strength functioning.
As discussed in the introduction earlier, we know that nuclear reaction in stars is nuclear fusion. So, what is nuclear fusion? Nuclear fusion is the process where light nuclei, like hydrogen, combine to form heavier nuclei, like helium, to release energy. Now, you must be wondering, how does fusion happen in stars? Because, as we all know, protons repel each other because they are both positively charged. This is called the Coulomb repulsion. But in stars, fusion can still occur because of quantum tunneling, which lets protons penetrate the repulsive barrier and come close enough for the strong nuclear force to hold them together. So, how does fusion releases energy? This can explained by the infamous Einstein's mass energy equivalence, which is E equal mc squared. During nuclear fusion, light nuclei combine to form a heavier nucleus. However, the final mass is slightly less than the initial mass. This missing mass is called the mass defect. According to the equation E equal mc squared, the lost mass is converted into energy. This explains why stars can produce enormous amount of energy from very small amount of mass. It is also the reason why the sun and other stars shine so brightly. In fact, this shows that mass itself is a form of a stored energy. Now, why is nuclear reaction in stars important? First, it supports life on Earth. The sun's fusion produces energy that reaches Earth as sunlight. This is important because in photosynthesis, plants use sunlight to make food, called glucose. This forms the base of most food chains supporting nearly all living organisms. Second, climate and temperature. Solar energy keeps the earth warm enough for liquid water to exist. It also helps maintain stable climates, which are necessary for life to survive. Next is evolution of the universe. When stars undergo nuclear reaction, they create heavier elements. These elements are released into space and mix with gas and dust. Over time, this material comes together to form new stars, planets, and entire solar system. As this process continues, galaxies become richer in a variety of elements. Planets like Earth are formed from these heavier elements. Elements such as carbon, oxygen, and nitrogen are especially important because they are essential for life. Without nuclear reaction in stars, the universe would mostly contain hydrogen and helium, and life as we know would not exist.
Now, we are going to look at example related to nuclear reaction in stars. Stars power themselves through nuclear fusion reactions. Like Sun, the proton-proton chain is the main energy source, fusing a hydrogen into helium at 15 million Kelvin. In stars, much heavier than the Sun, the hottest CNO cycle takes over using carbon, nitrogen, and oxygen as catalysts to fuse hydrogen much faster. Lastly, we have supernova nucleosynthesis, which happens at the very end of a massive star's life. When normal star fusion stops at ion, the violent energy of supernova explosion forces rapid neutron capture, creating the heaviest elements like gold and uranium. Essentially, these precious metals are scattered into space by dying stars.
So, how can we apply this in our daily life? First, it gave us food and oxygen. The sun's nuclear fusion releases light energy that travels to Earth. When light hits plant leaves, it causes photosynthesis. Photosynthesis releases oxygen and glucose. Glucose is important for humans to get energy by eating plants or eating animals that eat plants. Oxygen is important for every life on Earth for respiration. Next is solar power technology. As we know, fusion in the sun produces sunlight. When sunlight reaches solar panel, it converts sunlight into electricity. Electricity is helpful for us as is it used for devices like our smartphones, and it also gives us light. Next, it also helps machines and industry in factories, which created the clothes that you are wearing right now.
Now, let's look at recent studies that have brought major breakthrough in how we understand these stellar reactions. In 2023, researchers updated theoretical prediction for reaction rates across different stellar burning stages. By combining advanced statistical mode with experimental data, they give us a much clearer picture of how both light and heavy nucleus behave inside stars. Moving into 2024, advances in experimental facilities have been a game changer. Underground laboratories and particle accelerators like Luna facilities and India's Ferna accelerator now allow scientists to precisely measure fusion reaction at actual astrophysical energy levels. This helping us address long-standing challenges like cosmological lithium problem. Also, in 2024, new measurement of carbon-12 fusion rates have revealed a massive impact on stellar evolution and nucleosynthesis. Especially, we have learned that rotation-induced mixing inside massive stars significantly amplifies the production of heavy process elements. This discovery showed that our understanding of the universe's ultimate engines is constantly evolving.
Hello everyone, my name is Rifa Abadisha Petrapizo, and today I will be presenting about nuclear reaction in stars and career opportunities related to this topic. There are several career opportunities related to nuclear reaction in stars. One of them is an astrophysicist. Astrophysicists study the universe by applying physics to understand stars, galaxies, and nuclear processes like fusions. They also analyze data from telescope and space instruments to explain how the universe works. Another important career is nuclear engineer. Nuclear engineer work with nuclear reactions such as fission and fusion to produce energy. In addition, a fusion energy researchers focus on developing fusion technology, which is the same process that occurs in stars. Their goal is to create a clean, sustainable energy sources for the future. Lastly, a space scientist or aerospace researcher studies space phenomena and help develop technologies such as satellites and telescopes for space exploration. So, to achieve excellence in career related to nuclear reactions, several important skills are needed. You need strong knowledge in physics and mathematics. You also need good analytical thinking to understand data and solve problems. Technical and research skills are important too when we're working with scientific tools. Lastly, creativity and problem-solving skills are needed to develop new energy in science and technology. So, to achieve excellence in career related to nuclear reactions, several important skills are.
To begin with my first slide, continuous self-development is very important in this field because physics is always changing, so we need to stay updated with the new discoveries such as new findings about the star or the data from the telescopes. At the same time, learning continuously helps us to improve our thinking skills so that we can solve difficult problems in research like analyzing the data or understanding the theories. Next, it also helps us to get a better job opportunities because when we learn about the new tools or new skills, we can become more valuable to the research lab and the industry. For example, when we learn about the simple programming like Python, it can really help us. So overall, continuous learning helps us turn what we study into a real life application and discoveries. Now we are on my second slide to talk about key challenges in the field. Even though the continuous learning is important, to build a career in physics is also not that easy. One of the challenges that many concepts in modern physics are very difficult and usually take a long time to understand, especially hard topics like quantum mechanics or relativity. There is also pressure to do well, to produce results, to publish a research, and to get funding. Moreover, another challenge that we need to learn both physics and modern skills like coding, AI, and data analysis. For example, scientists now use computer simulation to study the stars. Besides that, it sometimes feels lonely in this field because it is very specialized, so it may be hard to find mentors or proper resource, especially at the beginning. For my last slide, we are going to talk about strategies for overcoming challenges. To deal with those challenges, we need to use the right strategies to keep improving ourselves. And one way for that is by using learning sprints, where we have to spend a fixed time each week to focus on one skill, such as programming or data analysis. This can help us to improve ourselves step by step without feeling too stressed. And another useful way is networking, where we can connect with other mentors and friends to get support and advice. For example, by joining group or attending talks. We also should plan our goals properly, including both short-term and long-term goals, so that we can manage our study and personal growth better. And lastly, we can track our progress by breaking big goals into smaller steps, which help us to stay motivated. So personally, I would using this method as I work towards my goal of becoming a researcher in modern physics.
In conclusion, we have shown that stars are basically a giant natural nuclear factories. They use nuclear fusion to squeeze hydrogen atoms together into helium. Even though there are massive energy barriers in the way, a neat physics concept called quantum tunneling allows this to happen anyway. This releases the huge amount of energy that keeps stars shining and creates the heavy elements needed for life to exist. Now, studying this reaction in a lab on Earth isn't easy. Scientists face real-world challenges like their equipment wearing down over time, background noise from space messing with their data, and dealing with elements that disappear too quickly. But by using advanced particle accelerators and smart math models, researchers are finding ways to get accurate data. Ultimately, understanding how stars work does more than just explain the universe. It gives us the exact blueprint we need to build clean, unlimited fusion energy right here on the Earth.